Thank you. I hope that the recordings are helpful. I know you don't have to look at every single recording, but I try to give a description so you know, like if there's one topic you want to look at, you can look at the descriptions and tell which class is covering that topic. Okay, I'm giving.
Yes, Professor, they're very helpful.
Oh, okay, great. Because it's not hard to do, but I have to download it to my computer, which takes time. Then I have to upload it to YouTube and then download it to Blackboard. So all of these, sometimes it can take quite a bit of time. Just takes the computer time. It doesn't take my time really. Okay. Okay. Did you need a potato chip or anything? Oh, okay. Didn't realize I had one of these.
I always like extra dip. She really liked it. I can't believe it.
You want to take it home?
I'm making two, because one's on top of the
I put it in the oven now. It's warming up, so you know.
Oh, I'm gonna take it.
You can take the whole thing because I have the one in the refrigerator, so I can just, this way it's sort of like, overnight. Okay. I think we should get started on these now. And if you have any questions, you can ask me. We're asked to factor 6x to the third plus 6x squared minus 36x. Now this is factoring. It's not an equation. You're not asking. Let me just, I keep getting this, my internet is unstable, so I'm going to check. Melissa, I'm making you the host.
Okay.
Okay. David? Are you on your computer that I'm running into? Again, I'm getting this unstable. Oh. No. Thought it was somebody using my computer. Okay. So we want to factor this thing. And the first thing we always look for when we're factoring is there a common factor? And I first look at the numbers, 6, 6, and 36. So obviously, the greatest common factor on those numbers is 6. Also, each of the terms have an x in them. So since the lowest exponent of all the x's is just the plain x, or x to the 1, 6x is my common factor. And I'm going to pull out the 6x. I'm going to factor out that 6x. And I'm going to divide 6x cubed minus 6x. So the 6's cancel and the x into the x cubed, remember we're subtracting exponents, gives me x squared. The 6x into the 6x squared, again, the 6's cancel out and the x into the x squared gives me x. And the 6x into the negative 36x, so 6 into negative 36 is negative 6. And the x's cancel out. So that's my first thing. I factor out any common factors that I can. I don't first start trying this AC method. That's only after I have no common factor. But I still have to factor the x squared plus the 6x minus 6. And for that, I'm going to use my AC method. So the A, of course, in this, I'm just looking at what's in the parentheses is 1. 1 times negative 6, my AC is negative 6.
Yeah,
Since it's negative, we know one number is going to be positive and one number is going to be negative. And we need those numbers to multiply to 6. And since this is minus, that means subtraction. They're going to subtract to the number that's in front of the x. Well, there's no number in front of it, which means it's 1. So the numbers that multiply to 6 and subtract to 1 are 3 and 2. Since the middle term is positive, I'm going to make the 3, the larger one, the positive, and the 2, the negative.
2x.
And put the x's next to it. Bring the x squared down. Bring the negative 6 down. Okay, I'm going to just erase this part because I never leave myself enough room, I see. Here's my 2, it's a solve, but now it gives me a little bit more space. I'll worry about the 6x after I do this factoring. In the first group, I'm doing group. This is x times x plus 3. In my second group, obviously it's going to be a negative because my middle term is negative, and negative 2x and negative 6, it's a negative 2. Negative 2 into negative 2x gives me x. Negative 2 into negative 6 gives me positive 3 as well. I know I'm on the right road because these parentheses are the same. So my final answer for this part is the x plus 3 times, well, what's on the outside is x minus 2. Again, it wouldn't have mattered if you would put the x minus 2 first and the x plus 3 second. But don't forget, there was a 6x from before. So this would be the answer of the factoring when we want to factor. Does anybody have any questions on how to do that type of factoring? Again, don't forget that what you want to do is take the common factor out first. Okay. And then we're going to start the second one. If I'm going to need the space, I'll go over there. Again, while I have it on the board, don't forget the midterm is next Friday. Instead of coming to class, instead of going on Zoom, you're going to go onto Blackboard and you're going to find your midterm there. Again, it's going to be similar in setup to the test one that I gave you on Blackboard that you that's due by the 21st. I'm going to be available on email during that whole time, because I know sometimes people get knocked off. You might get knocked off because of your internet. You might push the wrong button and you think you're just going to the next question and you're at the end of the thing. Usually they give you the option. What you won't have is more, I'm not sure, I haven't gotten the exact exam, but usually it's 20 questions, again, multiple choice. It's definitely going to be multiple choice. It's going to be multiple choice questions, and usually they give an hour and a quarter. Whatever it is, I'm going to set it up. But once you start the test, you can't walk away from it. You have to finish the test in one sitting. Okay, so I'm going to leave that on here. And let's now look at question number 2, which we were asked to solve. And we know, since it has an equal sign in it, we know it's an equation. And the first step should be to remove the parentheses. So we see actually what we have. And when I remove the parentheses, I do x times x is x squared. I'm just doing the distributive property. And x times -5, which is -5x. And I have this plus 6 from before. So the first thing I wanted to do was remove the parentheses. We do this anytime we have an equation. Unless it's 2 parentheses on one side and it equals 0 on the other side, and that really means they've done the work for you, most of the time you have to clear it so you see what you have. And we see, since there's an x squared in this equation, that what we have here is a quadratic equation. And if it's a quadratic equation, we want to factor it and set each of the factors equal to 0. Or alternatively, we could go to the quadratic formula. You have your choice. On a quadratic equation, you can either factor, which is usually the easier or quicker way to do it, or use the formula that we learned, -b plus or minus b squared over 4 minus 4ac over 2a. That formula. We're going to see later in the term that there are certain quadratic equations that can't be factored, and then we'll have to use that formula. But when you have a factorable one, you have your choice of both methods. Now, if I want to use the AC method on this, the A again here is 1, the C is 6, so my AC is +6, which means I'm looking for 2 numbers that are going to be the same sign, and since the middle term is negative, they're both going to have to be negatives. And they're going to have to multiply to 6, but when I add them, they're going to add to 5. I think everybody would agree that the numbers have to be 2 and 3. And of course, we put our x next to each of them and bring down the x squared and bring down the 6. And in my first group, I factor out the x and I get x minus 2. In the second group, it's starting with a negative, so my sign between the 2 groups is going to be minus, and there's a 3 and a 6, so common factor of 3. So -3 into -3x is x. -3 into +6 gives me -2. And which gives me, I'm trying to think where. Let me ask you, can I erase this top question now? Anybody still want that top question?
You can erase it.
Okay. Because I just want to go on, I'm sort of running out of space on the bottom. Okay, so on the bottom, I'm going to rewrite it. I have the x times the x minus 2 minus the 3 times the x minus 2. That's now equal to 0 because I factored it, which gives me the x minus 2 in front and x minus 3 in my second parentheses, because that's what's on the outside. And since I want to solve this, since this is a quadratic equation, it was not just a factoring, it said solve. I have to go further. I have to set each of these equal to 0. X minus 2 equal to 0 will give me one answer. X minus 3 equal to 0 will give me my other answer. And when I bring the 2 over here onto the other side, I get one answer to the x equals 2. And here I bring the 3 to the other side, and it gives me 3. So don't forget, with quadratic equations, you do get 2 answers. The 2 answers that we got in this case are 2 and 3.
Professor,
Yes.
how do we know when it's a quadratic equation? Because that one looked like the first one, so what's the difference? What would be the difference?
Okay, so in the first one, first of all, the instructions. You have to read what they want you to do with something. Don't just go do a problem, look at what it says. The first one said factor. The second one said solve. Factor means just separate. Solve means go all the way to the x. The other clue is that when we started this question, it didn't just stop over here. There was an equal sign in it, and there was something, it doesn't have to be 0 on the other side, though when it's a quadratic equation, we want to get it to equal to 0, but you have to have an equal sign. The factor one was just an expression. There was no equals in it at all. So those are your two simple ways of telling. First of all, by looking at the instructions, and second of all, by looking to see if there's an equal when it starts out. I didn't put that equal there. It came like this. Is that clearer?
Yes.
Okay. Any other questions on these? Again, these are examples from actually chapter 4. Now, I was asked to go over 3 problems from that I gave you on the test, the Blackboard test. Now, these are the 4 actual problems. The 3 actual problems. I'm going to go do problems similar to this at the end when I'm doing the review. At the end of the period, at around 11 o'clock, I'm going to do some review again. And I'm going to review these 3 types of questions. If anybody else has any questions, you can certainly bring them up anytime during the review sessions. But I definitely will go through the questions of writing an equation of a perpendicular line, something about a perimeter, and something about a systems of equations. We've done a couple, but let's do another one just to get it under our belt. Okay? Everybody with me? Okay, I'm going to erase this now.
Yes.
Okay. Any question? Can I erase this? Okay,
Yes.
great. Thank you. And we're going to continue with what we were, because I don't want to get behind on this. This is the problem, is when they give the midterm and really we should be in the next chapter. I don't want to get behind on that next chapter. So I'm going to continue with what we were talking about on yesterday. And we talked about what we called rational expressions, which were basically fractions that have x's and y's in them, letters in them. And we talked about doing 3 things. We talked about reducing a fraction. We talked about multiplying fractions. We talked about dividing fractions. And I'm taking this problem sheet that I sent you, and I'm just going to do some of the examples that are on that problem sheet. Just as a matter of interest, if you want to see the whole department, mathematics department review set of questions for the midterm, I posted it on Blackboard in, I think, in information. I posted the questions, and I also posted all the answers. They are basically, I've been giving you these type of questions chapter by chapter, but if you want to see them all together, then you can see it in information. Just look on information on Blackboard. Otherwise, you can just take each of the individual sections and look at them, because that's how I've been posting them. Okay. So let's say I got here's the question. They want me to simplify this expression. A squared minus 14a plus 45 over a squared minus 81. So this is, again, a rational expression. It's a fraction that has, in this case, polynomials in both the numerator and the denominator. We talked about what we do when we have monomials. We just look piece by piece. But when we have polynomials, when we have things that are separated either by plus or minus signs, then our first step always has to be to completely factor the numerator and the denominator. And again, that's why we've just done a chapter that involved all this factoring. So we have to know how to factor. So doing that, I'm going to look at my numerator, a squared minus 14a plus 45. And I'm going to do my AC method. My a, the number in front of the a squared is 1 times 45. It's a positive 45. I'm going to do this right over here. Since it's positive, I know both of the numbers are going to have the same sign. Since the middle is negative, they're both going to be negatives. And they have to multiply to 45 and add to the 14, which is obviously 9 and 5. And of course, we put our a's next to it. And this becomes the a squared, and this is the plus 45. I think we're pretty good at factoring this already. This has a common factor of a, so this becomes a times a minus 9. And this has a common factor of negative 5. And that's a, again, negative 5 into positive 45 is negative 9. So that factors the numerator, the top factors to a minus 9 times a minus 5. That's our numerator. Let's talk about the denominator. The denominator is a squared minus 81, which is just two terms. It's not a trinomial. So I don't have to use the AC method on it. I look first, is there a common factor? And there isn't, because this is just A's and this is just
9.
numbers. There's no common factor, but it is, what do we call it? How do we factor something like this? Do you remember we call this the difference of squares?
Two square.
This is a perfect square, and this is a perfect square, and there's a minus in between them. So we right away break it up into two parentheses. We factor the a squared into a and a. Since this is a minus, so one's going to be plus and one's going to be minus. And 81 is 9 times 9. So remember, it factors into what we call conjugate binomials. The two binomials look the same, except one has a plus and one has a minus. Now these are A's and these are 9s. They look a little too similar, but that's my handwriting. I'm sorry. once we have everything totally factored, then we look to see if there's anything that we can cancel out. When it comes to binomials, or any polynomial, but we're really mostly going to be dealing with binomials, you can only cross out a whole factor, which means a whole parentheses, a whole unit. I cannot take the A here and could cross it out with the A here and the 9 here with a 9 here. I can't do it by pieces. I can do it by pieces when I have monomials, when there are no pluses or minuses. But when I have binomials, I have to look for a whole unit. So I look at this A minus 9 and I look, is there anything that it can cancel out with? And there is an A minus 9. It has to be identical. I can cross out this A minus 9 with this A minus 9. Now the A minus 5 and the A plus 9 can't be canceled out. You cannot do anything even though they both have A's in them. So your final answer becomes A plus 5, I'm sorry, A minus 5, I don't know why I'm writing A 9 plus. A minus 5 in the numerator over A plus 9 in the denominator. That is how we deal with
Professor,
Yes.
how did you get the A plus 9?
When I factored A squared minus 81, and this is a very important type of factoring you have to know how to do, what we call the difference of squares, where there's the first number is a square, this is A times A. The second number is a square, it's 9 times 9, and there's a minus in between them. When you factor it, you get the A plus 9 in one parentheses, the A minus 9 in the other parentheses. Remember, it has to be a plus 9 and a minus 9 in order to give you the negative 81. One has to be plus and one has to be minus. If this would have been A squared plus 81, we couldn't have been done anything with it. It's only when it's a minus in between and then in the parentheses, in the factoring, one becomes a plus and one becomes a minus. Any other questions?
No.
Okay. Can I erase this now? Or should I leave it on the board for a bit? Okay, let me put one on the board for you to try. And here's one for you to try. While you're doing this, I'm going to take attendance. We have x squared minus 16 in the numerator and 6x plus 24 in the denominator. See if you can reduce this. See if you can simplify this fraction. While you're doing that, I'm going to be taking attendance. Azia, I know you're here. Nashia, I know you're here. Annabelkus. Annabelkus here? Emma. Emma, you're here?
I'm here, yeah.
Oh, I'm glad you're back. I missed you.
Oh, thanks.
I was gonna email you and find out if you weren't here today, I was gonna email you because I
Oh
know.
no, I'm here. I had to be here.
Okay, I'm glad you're here. Messiah. Messiah here?
Yes, I'm here. I'm sorry.
Okay, great. I'm glad you're here. April, I know you're here. Well, we talked before. Khadija. Khadijah's always here. Where's Khadija? Khadija? Umar. Umar. You were here yesterday, weren't you? You came in.
Yeah, I mean, I got it late though.
Okay, so I just changed you. You're, okay. Yakima,
Here.
good. Cheryl, I know you're here. Stacy, I know you're here. Natalie. Natalie is always here.
I'm here.
Yeah, okay. I'm glad you're here. Erica. I'm pretty sure I saw you. Erica?
Good morning.
You're also on.
It's Erica.
This class is amazing. You have great attendance. Last term, I was going through it. Everybody was absent. I'd have 42 people in the class and 10 would show up or something. It was really frustrating. Jonathan, I see you're here. Luke. Luke, you here? Layla, I see you here.
Yes, I'm here.
Good. Ashley, I know you're here. Ashley? I'm pretty sure I saw you before. Am I wrong? Oh. And this Ashley is not here. Okay, I thought I saw her. Kachira. Yeah, you're here. Jennifer, you're here. We were talking. Rachel. Gloria. Corey. Okay, Denise, I know you're here, and Devon, I know you're here. Okay. Okay. Anybody want to tell me what they did with this example? Anybody have? Let's see if anybody got it right on the chat. Okay, I see Devonna, it looks like. Looks like you did it right. Okay. Oh, no, that was from the previous one. That's not this one. Okay, let's do this together. We want to, can we factor x squared minus 16? Anybody have any idea? Can this, remember, these are both binomials, so we have to factor them.
It'll be like x plus 4, x minus 4.
Yeah.
Great. That is our difference of squares. So it becomes x plus 4 and x minus 4. What about the 6x plus 24? Is there any way to factor that?
I factored it as I divided both sides by 6 and I had 6 parentheses x plus 4.
Right, it has a count. Don't forget to always look for a common factor. Thank you, Jonathan. The 6 is a common factor. The 6 goes into 6 and 6 goes into 24. So we have 6 on the outside and x plus 4 on the inside. And therefore, I can cancel out the x plus 4 with the x plus 4. Don't ever try to cancel out an x minus 4 with an x plus 4. It has to be the same exact binomial, what we're left in the numerator is x minus 4 and 6 in the denominator. Now here's something you're going to see. This binomial really is as if it's in a parentheses. When you only have a single binomial in your either numerator or denominator, you don't have to put the parentheses. But remember, this x minus 4 is as if it's in a parentheses, which means it's a single unit. I can't deal with the 4 and the 6. The 4 is not a factor. There's a plus or a minus here, so I can only deal with a whole x minus 4. That's the most common mistake, is not realizing when you can separate something and when you can't. And it's interesting, when things are just connected right next to each other, which means they're connected by multiplication, you can separate and take different pieces, a part of it. But when things are connected by pluses or minuses, those are units and they have to be kept together. All right. Now I made this statement, and then there is they always say the exception proves the rule, which means it tests the rule. There is an exception about two binomials being identical and being able to be reduced. One exception is, let's say I have something like this. I'm going to give it to you in the factored form. I'm erasing this now. Suppose I had factored something and I had gotten 4 plus x over 4 minus times 4 minus x over 6 times x plus 4. Let's say that is what had come out of this. In other words, suppose it had been 16 minus x squared. And I asked myself, can I reduce it? And I see on the top I have a 4 plus x. And on the bottom I have something that's very similar but not identical. This is an x plus 4. These look exactly the same, except their order is reversed. Here we have the 4 first and the x second. Here we have the x first and the 4 second. So the question is, can we reduce it? Can we cancel it out? And of course we can, because x plus 4 means the same thing as 4 plus x. When you change the order in which you're adding, you don't change the value. So therefore, I could cancel out this x plus 4 plus x with the x plus 4 and get my answer as 4 minus x over 6. So there's exception number 1. The two binomials look exactly the same except the order is switched. If there's a plus in each of those binomials, then you can totally cancel it out, because it's called the commutative law. When you change order, if I do 2 plus 3, I'm going to get 5. If I do 3 plus 2, I'm going to get 5. So that works. So that's exception number 1. There's another exception. It's even a little more complex. What if I had given you this question? Okay, suppose I had factored. Can I erase this? Because I don't want you to get mixed up with this. Okay, let me go to, let's say I had 16 minus x squared over 4x minus, no, it was 6x. I'm sorry, I'm trying to get almost the same question. 6x minus 24. And again, I want to factor this because these are a binomial on top, a binomial on the bottom. I can only cancel out like binomials. So the top is a difference of squared. 16 is a perfect square. 4 times 4. X squared is a perfect squared. It's x times x. And in one parenthesis, we have to put a plus, and one we have to put a minus. Notice this factors to 4 plus x and 4 minus x because this 16 came first, so the 4's have to come first. And the x squared came second, so we had to put the x's second. If I factor the denominator, my common factor again is 6. This becomes 6 minus
X plus 4.
6 times x minus 4. Okay, but if I see something, what I see on the top is a 4 minus x, and on the bottom I see an x minus 4. Are those exactly the same? When it was plus, we said it was exactly the same because we said when we add it doesn't make a difference what order we add it, we get the same exact result. But when we're subtracting, that's not quite the case. Let's look what happens when we subtract. I want you to realize what we're doing. So let's just take some subtractions. Suppose I do 5 minus 3. What will my answer be? Obviously, 5 minus 3 is positive. 2. What is 3 minus 5? Is it 2 also?
Negative 2.
Negative 2.
Yeah, negative 2. Let's take another number. 12 minus 1. How much is that?
11.
Oh, but how much is 1 minus 12?
Negative 11.
You see a pattern?
Yeah.
You're not getting exactly the same answer. You're getting the same number, but one is coming out to be positive and one is coming out to be negative. Well, that's exactly what we have here. We have a 4 minus x being one answer, and x minus 4 being giving me another answer. And they really are identical, except one of them is a positive number and one is a negative. If x is 1, then the top becomes 3 and the bottom becomes negative 3. Whatever the x is equal to, the number on top and the number on the bottom are going to be the same absolute value. They're going to be the same number value, but one is going to be a positive and one is going to be a negative. That always happens when you switch the order in which you're subtracting. What changes is not the number itself, but just the sign. This always happens. Well, what happens what if I took 2 on the top and a negative 2 on the bottom? Could we reduce this? Could I reduce a 2 over a negative 2?
So would it be 1?
Would it be positive 1 or negative 1?
Negative.
Negative 1. If I have negative 11 over 11, again, it's negative 1. Anytime I have two numbers that are opposite in sign, one over the other, they reduce. Remember, they don't reduce to nothing. They reduce to negative 1. So when the same thing happens over here. When I have a 4 minus x and an x minus 4, I can cancel them out as long as I put a negative 1. My answer is not 1. It doesn't totally cancel out. It cancels out to a negative 1. So that's our other exception. If my two binomials are identical, except their order is switched and there's a minus, I can cancel them out as long as I put a negative 1 in place of one of them. Now, I always put the negative 1 on the top. It's much easier to do with a negative in the numerator than in the denominator, and I always have this choice. I could put the -1 in the bottom, I could put the -1 on the top. I always put it on the top because that is the more acceptable way and it's the more useful way. So if I look now, if I go back to this example that I was doing, I can cancel out the 4 minus x and the x minus 4, but since there's a minus, I have to put a -1 there. So my final answer, and it could be written, I'm going to show you 3 different ways we could write the answer. We could write the answer with a -1 times 4 plus x over 6. Usually we put the single number in front of the binomial if we have a choice. Or we could have distributed out the -1 and do -4 times minus x over 6, just multiplying both terms in the parentheses by -1. Or another way we could have done it is this -1, we could have just put it as a negative in front of the whole fraction and written 4 plus x on the top and 6 on the bottom. A negative in front of a parentheses is the same thing as multiplying the whole numerator by -1. The negative goes with the numerator. Somebody's is not muted and there's background noise. Can you please mute yourself? So here's where we have to be cautious in terms of simplifying fractions, that if we end up, after we factor, that the 2 factors look identical except for the order, that if there's the plus between them, you could just cancel them out. But if there's a minus in between them, you have to put a -1 in place of one of them, preferably the one in the numerator. Okay, now after this whole long discussion, I want to do another problem. And actually, I want to do a problem that involves multiplication or division. And after we finish, I'm going to do one with you, and then I'm going to give you time to do one on your own. So let's say I gave you this example, x squared minus 9 over x squared. This happens to be on the exercise sheet that I sent you out. It happens to be example number 6. X squared minus 10x plus 24 divide by x plus 3 over 2x minus 12. Now, what we're going to see is that these problems can get very long and complicated. And the biggest thing you have to do is be able to factor properly, number one. And secondly, you have to be very neat, because if you're going to be sloppy, you're not going to be able to see. If you start scribbling things out, you're not going to be able to see what you're doing. So I'm going to try to do it as large as possible so you can see what I'm doing. My first step, there are 2 first steps. First of all, the fact is that I know this is a division problem. And we said when we're doing division with fractions, the easiest way to do division with fractions is just to flip the second fraction. Take the reciprocal of your second fraction, and then you just have a multiplication problem. Also, so let me rewrite it. Okay, so we have x squared minus 9 over 10, I'm sorry, x squared minus 10x plus 24 times 2x minus 12 over x plus 3. I changed the division to a multiplication by taking the reciprocal, in other words, flipping that second fraction. Now, we know the rule in multiplication is that you have to multiply the numerators together and you have to multiply the denominators together. But if we start to multiply these things, first of all, I have to do FOIL in the top, and on the bottom, I can't even do FOIL. I'd have to multiply a trinomial by a monomial, and then I'd have to try and factor to see if I could reduce anything. So if you remember, I talked about something called cross canceling. What you can do is totally factor everything first.
X
First
minus
of all-
3.
Right, so this becomes the x squared minus 9. Who said that, by the way?
Ivana.
Somebody- Okay.
Ivana.
Right, so we've got x plus 3 and x minus 3. Again, this is a very common type of factoring, this factoring of the difference of squares. It's an x squared minus 9. That's going to factor to x plus 3. I'm going to put this a little lower down. So that takes care of that first. Now I have to go to the x squared minus 10x plus 24. And I've got to factor that. Well, that's a
Professor?
trinomial. So I have to use my AC method, right?
Yeah.
My AC is positive 24. So I know I'm going to need either two positive numbers or two negative numbers. But since the middle is negative, I'm going to need two negative numbers.
I use 4 and 6.
Right, because they have to multiply the 24 and they have to add the 10, so that's
4x
4x
and
and
6x
6
plus 24.
And here's my
X squared and plus
and this
24 in
is
the
my
end.
24. So this is x times x. And this becomes, what's my common factor over here?
Over there, I put positive 6.
A positive or negative?
Wait, I can't see. Why it got so blurry? Negative 6.
It's a negative
can't-
6 because remember
Okay.
the 6 is negative.
Plus
So that's
24.
x.
X
Okay.
plus 24.
So that becomes x minus 4 in one parentheses and x
And
minus
X
6 on the other parentheses. So that's, I know this is a little squashed. I need 20 boards. I have to go around. I have to tell you, my favorite professor in graduate school was somebody I went to Brooklyn College and we had boards all around 4 sides of the class. And he used to start at one end and start the class and he'd go all the way around. And when he got to all the way to the other end, that was the whole class. It took him that's how long it took him. He never had to erase anything. But unfortunately, I don't have that kind of boards. Also, I'm not as neat as he was. Extremely neat. Okay, so for that first fraction, I got x plus 3 times x minus 3 on the top. And on the bottom, I got x minus 4 times x minus 6 on the bottom. Okay. Now we're up to our second fraction. Notice I haven't done any multiplication. I'm first doing all that factoring. Is there any factoring I can do in the 2x minus 12?
Yeah, I put 2, parentheses, x minus 6.
Right. As we always look for, we have a common factor of 2. And of course, the x plus 3, there's really nothing to do with that. Now, all you have to do now is look. Remember, even though this x plus 3 is not in the parentheses, it's as if it's in the parentheses. We just didn't have put in the parentheses because there was nothing else there. I go along my numerators, go along my tops and see if there's anything in the denominator that I can cancel it with. And it's easy with the binomials because they have to be identical. The only difference could be is if you switch the order. You can't switch the sign, just the order. Now there's an x plus 3 on top, and I notice here's an x plus 3 on the bottom. They can cancel out. The next thing I see is an x minus 3 on top, but I don't see any x minus 3 on the bottom. I leave it alone. Then I see a 2. This 2 is a standalone. So I could only cancel it out with a standalone 2, and there is no standalone 2 at all. So I leave the 2 alone. And then I have an x minus 6 on the top. And I see there's an x minus 6 on the bottom, so I can cancel them out. Notice it could be any numerator with any denominator, but they have to be identical. If everything gets canceled out like they did over here, I really should put a 1 there. Now I can finish the question by just putting the numerators together and putting the denominators together. What do I have in my numerator? I have an x minus 3 in a parentheses, and I have a 2 outside the parentheses. You do not have to multiply it out. You can leave it factored. You can leave it separate. Though you put the 2, if they're single numbers, they usually go
X
first.
minus 3.
And on that takes care of the numerator. And
X
in the
minus 4.
denominator, the only thing I see left is an x minus 4. And here's my answer. Notice the big work here was a factoring, because once I get it factored, I was able to just cancel any numerator factor with any denominator factor. And notice the only difference between doing a division with doing a multiplication is this one step, flip the second fraction. Does anybody have any questions about that? Okay, I want to, yeah.
The denominator, if you say x minus 4, you wouldn't get points taken off. It wouldn't be deemed wrong if you put parentheses over the x minus 4, correct?
No, not at all.
Okay.
If you wanted to, you could write it like this.
Okay.
I'm just telling you though, if you're doing a midterm or a final, that if you won't see it with the parentheses as a choice, you'll see it without a parentheses.
Okay.
But there's absolutely nothing wrong. It's really as if it's in its parentheses. It's like when you have an X and you don't write it 1x, you just write it X, but you know the one is
There.
I won't say an imaginary one. It's a invisible one.
Yeah.
So here it's in the parentheses. You don't have to have that parentheses, but it's understood to be there. It's an invisible parentheses. But of course, if you have 2 of them, like you can't put an x minus 4 and x minus 6 next to each other. You have to put that parentheses because you have to separate them. But here the parentheses doesn't do anything, so you don't have to put it in. But it's certainly correct if you put it in. Questions?
Professor, so
Okay,
I
let's
just
remember
did.
what- Yeah.
I'm sorry. Finish your thought. I'm sorry.
No, you said, you go on. You asked the
Oh,
question.
I was saying that I didn't simplify it. I had put 2x minus 6 over x minus 4. Would that be correct? Or would I have to
Oh,
make
you
it?
mean if you left this as 2x minus 6, that would have been
Yes.
okay.
Okay.
Yes, that would have been, there's nothing wrong with it. But usually that meant that you then multiply. That's like sort of an extra step that you had to do. And it's better to leave it in the factored form, but it's not wrong. It's certainly not wrong. I'm just trying to think, and sometimes they would write the answer 2x minus 6 over x minus 4 because they don't want any parentheses. It's very hard to tell how they would put the answer. Both of them are totally correct. Any other questions? Okay, so let me give you one to try on your own. Again, I'm taking this right off this example sheet. This actually happens to be question 4 on that example sheet. It's 2x minus 3 over x squared minus 10x plus 25 times, and you can either use an x or you can use a dot, x squared minus 25 over 10x minus 15. And again, the bulk of the work here is factoring. Once you get the factoring done, the rest sort of goes, do I have to flip this one? Do I have to take the reciprocal here?
No.
No, because it's already a multiplication. Okay, I'm giving you a few minutes to try this. Okay, I see a bunch of people, or several people have already sent in answers to the chat. So I think we can get started on this. All right, so number one, we've got to factor. Did you have to factor the 2x minus 3? Did you have to do anything with 2x minus 3? Was there anything we could do with it? No. Okay, so therefore this stays 2x minus 3. What about the x squared minus 10x plus 25? Can anybody tell me how they factored the x squared? How do you factor x squared minus 10x minus 25?
Negative. Negative
Right.
4 and 5.
We got x minus 5, and what was the other one?
X plus 4.
You got plus 4?
Right.
Let's look at this. This one is the harder factor to do. Please, whoever's talking there, can you please? Azia, is it you? Oh, thank you. Okay. We're going to do our AC method on this one. So our A is 1 and our C is 25. So our AC is positive 25. So we're going to need two numbers that are going to multiply to positive, means both are either going to be positive or negative. They're obviously both going to be negative. I'm going to put it over here. And they have to multiply to 25, and when we add them, they have to give us 10. What multiplies to 25 and gives us 10 when we add?
X minus 5, X plus 5.
Yeah.
It's 5 and 5, right? Right, so this will be my x squared, and this will be my plus 25. So in my first group, I have x times x minus 5. And in my second group, I have a negative 5 as my common factor, and that becomes x, and also negative 5 into positive 25 is negative 5. So that this factors to x minus 5 and x minus 5. They're both minuses because they both have to have the same sign because the last term is positive. And since the middle term was negative, they both had to be negatives. So x squared minus 10x plus 25 factored into x minus 5 times x minus 5. Or you could have said, alternatively, you could have said it's x minus 5 with a square on the outside. But actually, for doing this example, it's better to have them written out. But this is a perfect square binomial because it factors into two binomials that are identical the same. When we get to the x squared minus 25, that's my difference of squares. So that's going to factor to the x plus 5 and the x minus 5. Look at the difference between what this looks like and this looks like. This is a trinomial. The two binomials turn to be both x minus 5. This is just a binomial, but it's the difference of squares. So we get the two binomials looking very similar, except one has a plus and one has a minus. There's the difference. What about in the bottom here? Is there anything we can factor there?
Yeah, I got 5.
You can put a friend on the side. And what do you get?
Parentheses 2 minus 3.
2x minus 3.
Yeah, 2x, sorry.
Now we can start reducing or cross canceling. Can I do anything with, remember, this is if it's, even though it wasn't in a parentheses, it's as if there's an imaginary parentheses there. What can that 2x minus 3 be canceled out with?
The bottom, 2x
Right.
minus 3.
Notice, since there's nothing else left here, I put a 1. I don't want to leave it anything blank. If there's something else left there, it's okay, but don't leave any numerator or denominator empty. Okay, now we have an x plus 5. Is there anything we can cancel out with that x plus 5?
I canceled out the x minus 5.
Are you allowed to do that? Can you cancel an x plus 5 with an x minus 5?
Yes? No.
No.
No, you have to cancel the x minus 5 and the x minus 5.
The only thing you can cancel are either an x minus 5 with an x minus 5, or
Mhm.
x plus 5 with an x plus 5, or an x plus 5 with a 5 plus x. You can change the order. You cannot change the sign in the middle. If they have different signs in the middle, they cannot be canceled out. But what about this x minus 5? Is there anything to cancel that out with?
Yeah.
Right. Either one of these.
So
What
then I
about
got,
5? Is there anything, can I do anything with that 5 on the bottom?
no, I left it.
No, you can't. Even though there's a 5 here and a 5 here, this 5 is a standalone 5. You can't cancel it with a binomial. So let's see what we're left with.
I
On the
got
top, we
x
just
minus-
right? And
And
on
then I
the
got
bottom,
5.
please mute yourself if you're not talking.
And then I got 5
And on the
parentheses x minus 5.
bottom, a 5 and a x minus 5. And I want to put that 5 first, because we usually put the single number first before we put the binomial. It wouldn't be wrong to write the x minus 5 and then the 5, but this is the more common way of writing it. You could have also written, leave the
X
x's
plus
on
5 and then 5x minus 25, right?
right. Either of these answers are completely correct.
I got both those answers.
You can take either one answer, and if this is an open-ended question, either answer would be correct. If it's a multiple choice, they'll only give you one of these choices because they can't give you both because they're both correct. So that's how we do. So right now, we're at the point where we can do reducing, multiplying, and dividing of fractions. On Tuesday, we're going to talk about adding and subtracting of those fractions. But what I'd like to do now is take these 3 questions that I'm trying to think who asked me. I'm terrible. Who asked me these questions?
Jennifer, she said it was her that she asked those questions.
Somebody came on early and asked me those questions, and I
Jennifer,
don't remember
Jennifer
who.
asked the questions.
I did, Professor
Oh, was
Jennifer.
Jennifer?
Mm-hmm.
Okay, but it doesn't matter who asked this. There was somebody who was working on the Blackboard test that I had given, and she ran into problems with these 3 types of questions. Obviously, these are the questions that are on the Blackboard test, so I'm not doing those exact questions, but I'm going to do 3 questions that are similar. I know can you hear me? Can you hear me?
Yes, I can hear you.
Yes.
Oh, okay, because I keep getting this, I don't know what I'm doing about this internet, because I don't know, we've tried rebooting, we've tried everything. And every so often it comes up. All right, so the first question happened to be with how do you get the equation of a perpendicular line where they gave you a point and a perpendicular, and they asked you to be perpendicular to a given line. So let's say I gave you, I'm going to give you a similar question, and we'll go through that. Suppose I give you, I have an equation.
Hello.
Suppose I gave you this question. I have 9y equals 7x plus 18 is a line. I want to write the equation of a line that's perpendicular to this line and goes through the point 0, 7 over 11. How do we do something like this? By the way, what does it mean when the x is the 0 of a point? What point is that called? When the x is 0, then this number is what we call the y-intercept, right? Because the y-intercept is always where the x is 0. So really, when they tell you it's going through the point 0, 7/2 or 0, 7 over 11, whatever, they're, in other words, telling you that your b is 7 over 11. Now, if they would have told me the point is 1, 7 over 11, I couldn't say that. I know the b, the y-intercept always happens where the x value is 0. And we know that we want to write the equation of the line, which is y equals mx plus b. Okay, and really we always work on the m first. We always want to try and figure out what is the slope of the line. Sometimes they give us 2 points and we can use a slope formula. But in this case, the hint was that they gave me a line and they told me the line that I want to write the equation of is going to be perpendicular to this line. And we know when lines are perpendicular, it means that their slopes are negative reciprocals. So the first thing I'm going to want to do is figure out what is the slope of this line. So I'm going over here. I'm going to start up here. Can you see? In order to find the slope, I have to get the y alone, which means I have to divide everything by 9. So my original line becomes y equals 7 over 9 x plus 18 over 9, which is just 2. Which means that the slope of this line, now that I have the y equals the number in front of the x, and that means everything excluding the x. If it's just a plain x there, if this would have said y equals x, then the slope would be 1. The number is the coefficient of the x. The slope is 7 over 9. And since my line is going to be perpendicular to this line, my slope is going to be negative 9 over positive 7. It's the negative reciprocal or opposite reciprocal, whatever you want to call it. You flip it over, switch its sign. So my equation now becomes y equals negative 9 over 7x plus b. But since they said the line is going through the point 0, 7 over 11, the b, I don't have to do any work on that. Usually I have to put in the x, the 0 for the x, and the 7 over 11 for the y. I don't even have to do that because I know anytime the x value is 0, the other number, the y, that is the y-intercept. So my equation then becomes y equals negative 9 over 7x plus 7 over 11. So that's how you would do any. Don't forget, if it talks about parallel, the two lines have the same slope. If the lines are perpendicular, the slopes are opposite reciprocals. Does that help you?
Yes.
Okay. So can I erase this now? Anybody want this still on the board? Okay. So let's do a question of the second type. That's a question about, both questions number 2 and 3 that you asked me were word problems. And they're the two type of word problems that you have to know for this midterm. One has to do with perimeter and one has to do with tickets or clothing or something, the prices of things. Okay, so let's erase this question. And suppose I gave you a question that sounds like this. The length of a rectangle is 8 less than twice its width. The perimeter is 44. Find the dimensions. I'm going to give you a few minutes to try this on your own. All right, I think let's try and work on this now. Whenever I have these questions that have to do with perimeters or rectangles, I try to draw a picture. Now, they told me the length of the rectangle is 8 less than twice its width. So since they're telling me what the length is in terms of the width, let's call the width the x. And then to say that something is 8 less than twice its width, twice means you have to multiply by 2, so that's 2x. And 8 less means you have to subtract 8. Don't do 8 minus 2x. It's the 2x minus the 8. Here it said 4 longer, so you would have to do longer is more, so you'd have to do plus 4. But when it says less, you have to subtract 8 less, you have to subtract the 8 from the 2x, the twice the width. Now this side will also be an x because that's also width, and this will also be 2x minus 8 because in a rectangle, the opposite sides are equal, and the perimeter consists of all the sides added up. So I add everything up, x plus 2x is 3x, 4x and 2x is 6x, and the negative 8 and the negative 8 gives me negative 16. So the perimeter in terms of x would have been 6x minus 16, and I was told that the perimeter is 44, so this has to equal the 44. And here's our equation that we have to solve. We add 16 to both sides. That gives me 6x equals, now this is 44 plus 16 is 60. So if we divide by 6, we get x equal to 10. Now the question is find the dimensions. When it says find the dimensions, it doesn't mean just the length or just the width. It means both. So we have to figure out the width we know is 10. To figure out what the length is, we do 2 times 10 minus 8. So that's 20 minus 8, which is 12. So the dimensions are 10 by 12. This rectangle has a width of 10 and a length of 12. Is that clear? Are we okay with that one? Any question? Yeah, you're okay with that one?
Yeah.
Okay, so let's talk about this last type of question. Actually, I'm taking one off of a previous.
Wait, Professor, Shirley wants to find out how did you get 12?
Okay. To get to 12, once I know that the x is 10, I go to the 2x minus 8 because that's what the length is. And I replace the x with 10. So that gives me 2 times 10, which is 20, minus 8. So therefore, there's how the 12 comes from. Are you okay with that? How about the 44? Now add them all. The 44 it gave us the 44, so we don't have to put the 44, but you could check. This is 10, this is 12, this is also 10, and this is also 12. If you add them up, that would be your perimeter. 10 plus 12 is 22, and 10 is 32, and 12 is 44. So it does add up to 44. You can always check your results, and you can see that your perimeter was 44. Okay?
Okay, thank you.
Okay. So let's do one. Can I erase this now? Okay, so I want to do one more type of question, We have 5 minutes, so we should be able to do it in 5 minutes. Here's the question. There were 410 people at a play. The admission price was $3 for an adult and $1 for a child. So there are two types of tickets. One is adult, they charged only $3 for, and for the children, they only charged $1. And the total amount of money they made at this play was $830. And they want to know how many adults and how many children attended this play. Okay, so I'm not going to give you time to work it out because I don't think we have time in class. Let's make a legend. Let's set X equal to the number of adult tickets. And let us call Y the number of children's tickets. But if you wanted to, you could call A the number of adult tickets and C the number of children's tickets. You can use whatever letters you want to use. Just know
$830
what your
is the total, right?
variable
The total
stands.
of everything.
Excuse me, I'm sorry, I didn't hear your question.
The $830 is the total amount of money, right?
Total from both types of tickets.
Okay.
Everything they,
So we can write 410 people and then $3 adult ticket, $1 for each child, and the total is $830.
right.
Okay.
Okay, what's my first equation that I'm gonna get? Anybody?
X plus Y equals 410.
Right, X plus Y equals 410, because X is how many adults there are, and Y is how many children, and we know there are a total of 410, so the X plus Y has to be 410. What do we do with the 830? What equation do we get with the 830?
You can put 3x plus 1y equals 830.
Right, 3x plus 1y, or just y, equals 830. Because now you have to include not just how many people there are, but how much each of them paid. And now we have to solve this. Do we want to get rid of the x's or do we want to get rid of the y's?
You can get rid of the x.
Okay, if we get rid of the x, that means I have to multiply the top equation by 3 and the bottom equation by 1, and then decide, do I need to use a negative or not? Should I use a negative at all?
You can turn yeah.
Yeah, I do, because they're both positive and I need one to be positive, one to be negative. It doesn't matter which one I pick to be the negative. Okay, so let's see what we get from here. So I'm multiplying the top equation by -3. That'll give me -3x minus 3y equals, okay, here's my calculator. I'm doing on my calculator, -3 times 410. I know I could do it in my head, but I don't have to. And I get -1230. And the bottom, I'm just multiplying by 1, so that becomes 3x plus 1y equals 830. It doesn't change at all. When I add these two equations down, the -3x and the +3x are eliminated. That's the whole point of it, to get rid of one of the variables. The -3y plus 1y gives me -2y. And the -1230 plus the 830 gives me -400. And then if I divide by -2, I get y equal to 200. So the number of children that were at this play were 200. And what does that mean about the adults?
That there had to be 210 adults because there's 410 people.
They have to add
Professor,
up
can you
the
lower your
210.
camera a little bit so I can see the bottom?
Is that better? Can you see it now?
Okay, y equals 200.
Y equals 200, right?
Okay.
So our final answer is 210 adults and 200 children. All right, I think that's, and I've gone over my time. I'm sorry. I've been 2 minutes over time. Have a nice weekend. Are you having class today, Melissa?
Professor, there's no homework. It's only the test. that
Yeah,
we-
I can.
Usually, people are either going out,
Okay.
they're hanging
I'm-
out, they're talking to, friends.
At this point, I'm not giving you any additional homework. I'm leaving you, first of all, you have to finish that test. If you have not completed any homeworks by this time, go back and do those homeworks. They're good practice. Do everything, but I'm not giving any additional homework at this point. On Tuesday, I will give homework because I think we have to do homework on the rational expressions. But at this point, I really want you to complete whatever has been given so far.
Professor,
Okay?
Professor,
Okay.
I'm having a hard time accessing Melmore.
Who's this?
It's Nashia.
You're having a hard time getting to the
Accessing.
homework?
Yeah,
You mean you can't get to the, because the Delta math homework?
yeah.
Do you know why you're having that trouble?
I don't. Is there any way you could send me a link or show me where? Because I didn't have a hard time the first few times, and now I'm having a hard time getting in.
What I'll do is I'll send. Does anybody know the code? If not, I'll send it to you. Do me a favor, send me an email, and I will send you the website and the teacher code.
Okay, thank you.
All right, any other questions? Have a nice weekend then, everybody, and don't
Have a
forget.
nice weekend, Professor.
Don't forget that next Friday is our midterm. It's going to be on Blackboard. You're not going to be on Zoom. You're going to be on Blackboard. And don't forget to do test 1 on Blackboard. And if you haven't completed anything on Delta Math, do that now as well. And if you find that something has been, if you can't get to something, just send me an email. I will respond. Have a nice weekend.
Thank you.
Thank you so much, Professor. Have a nice weekend.